Hello everyone! Today we are going to learn about rectifier circuits. The process of converting alternating current to direct current is called rectification. Automotive. Three-phase alternators produce three-phase alternating current. The electrical devices in the car work with DC power, which requires a rectifier to convert the alternating current produced by the generator to DC power. Here we'll look at three types of rectifier circuits. First, single-phase half-wave rectifier circuit. Second, single-phase bridge rectifier circuit. Third, three-phase bridge rectifier circuit. Okay, first of all, let's talk about the single-phase half-wave rectifier circuit. The diagram shows a single-phase half-wave rectifier circuit. A single-phase half-wave rectifier circuit usually consists of a step-down transformer, a rectifier diode, and a load resistor. When U2 is positive half-cycle, that is, U2 is positive above and negative below, diode VD is subjected to positive voltage and conducts. At this time, a current flows from the positive terminal of the power supply through the diode VD, the load RL, and finally goes back to the negative terminal of the power supply. The current IO flowing through the load is equal to the current ID on the diode. Neglecting the voltage drop of the diode, the output voltage UO across the load is equal to the transformer secondary side voltage U2, and the waveform amplitude of the output voltage UO is the same as that of U2. When U2 is in negative half cycle, U2 is negative above and positive below. The diode is reverse biased and cut off, and no current flows in the load. UO equals 0. The transformer's secondary side supply voltage U2 is all added to the diode VD, and the rectifier output waveform is shown in figure. The voltage output at the load has only half a cycle waveform, that is, a half-wave pulsating DC voltage. The DC voltage at the load, that is, the average value of the pulsating voltage at the load over one cycle. UO equals 0.45 U2. Maximum inverting voltage on the diode, URM, equals root 2 times U2. U2 is the effective value of the voltage on the secondary side of the transformer. Second, let's talk about single-phase bridge rectifier circuits. As shown in the diagram, it shows three common ways of drawing single-phase bridge rectifier circuits. The rectifier part of a single-phase bridge rectifier circuit consists of four diodes, VD1, VD2, VD3, and VD4. When U2 is in positive half cycle, U2 is positive above and negative below. Diodes VD1, VD3 withstand forward voltage and conduct, while VD2 and VD4 withstand reverse voltage and cut off. At this point, the path of the current is from the positive terminal of U2 through VD1, RL, VD3, and finally returns to the negative terminal of the power supply. The direction of current on the load RL is from top to bottom, so the polarity of the voltage across the load is positive above and negative below. The waveform of the voltage output on the load is the same as the waveform of the positive half cycle of U2. When U2 is in negative half cycle, U2 is negative above and positive below. Diodes VD2 and VD4 are subjected to forward voltage and conductive. VD1 and VD3 are subjected to reverse voltage and cutoff. At this time, the current path from the negative terminal of U2 through VD2, the load resistor RL, the VD4, and finally back to the negative terminal of the power supply. The direction of the current on the load RL is from above to below, so the polarity of the voltage across the load is positive above and negative below. The waveform of the voltage output on the load is the same as the waveform of the positive half cycle of U2. Comparing the waveforms of the input and output voltages, it can be seen that the sinusoidal ACU2 is transformed into a full wave pulsating DC voltage by the bridge rectifier. The DC voltage across the load, namely the average value of the pulsating voltage across the load over one cycle, is UO equals 0.9 U2. The maximum inverting voltage on the diode is URM equals root 2 times U2. Thirdly, the three-phase bridge rectifier circuit. The figure shows a three-phase bridge rectifier circuit. The primary windings of a power transformer are delta connection and the secondary windings are star connections. VD1, VD3, VD5 are common cathode connections, and VD2, VD4, VD6 are common anode connections. This is the voltage waveform of a three-phase bridge rectifier circuit as shown in figure. During the time period T1 to T2, phase A has the highest potential and phase B has the lowest potential. VD1, VD4 conduct, and the rest of the diodes are cut off. Current flows from point A through VD1, RL, VD4, and finally goes back to point B. The output voltage across the load is UO equals UAB. During T2 to T3 time period, the A phase potential is the highest and the C phase potential is the lowest. VD1, VD6 conduct, and the rest of the diodes cut off. The current flows from point A through VD1, RL, VD6, and finally back to point C. The output voltage on the load is UO equals UAC. During the time period T3 to T4, the B phase potential is the highest and the C phase potential is the lowest. VD3, VD6 conduct, and the rest of the diodes cut off. The current goes from point B through VD3, RL, VD6, and finally gets back to point C. At this point, the output voltage across the load is UO equals UBC. In this way, in one cycle, the output voltage across the load is the concatenation of the tops of the 6-segment wave, and the average value of the output DC voltage is UO equals 2.34 U2. Compared with single-phase rectifier circuits, three-phase bridge rectifier circuits output a smoother voltage waveform with less pulsation. Okay, so we've covered 3 types of rectifier circuits today. First of all, the voltage waveform output from a single-phase half-wave rectifier circuit is a half-cycle waveform with large pulsations. The second is a single-phase bridge rectifier circuit. The output voltage is a full-wave output. That is, the output signal is present throughout the cycle with a large pulsation. The last one is the output waveform of the three-phase bridge rectifier circuit, which is a full period signal. Its voltage waveform is smoother and has less pulsation. When it comes to rectifier circuits, it is important to understand how they work fully in conjunction with the waveform diagrams. At the same time, we should all learn to think in a dialectical manner and argue scientifically. That's all for this point. See you next lesson.